Okay, welcome to Unit 4. This is 2 parts. We are starting with Part 1, Lesson 4.1. This is the introduction to set theory. So set theory is talking about taking a bunch of items, categorizing them according to what they have in common and what they don't have in common. So that's what we're going to be talking about. So a set in math, we say, is a collection of items or elements. You'll see the word elements quite often. Now, there's a few ways that we can write a set. First of all, they're named and labeled by capital letters, but we can write our sets by listing them. So the first way is by listing. So we just list them, and we list them in what we call those curvy brackets. Those curvy brackets have a special name. They're called braces, actually. So the curly braces, they are an actual symbol, and they mean something in math as words. So you would read it as the set of. So A is the set of numbers 1, 2, 3, 4, 5, and 6. That's how we would read that. Now, we could also write it with words and do a description, okay? So words doing a description. So natural numbers less than 7. Okay, that also describes this exact same set right there, natural numbers less than 7. The next way is called set builder notation. The third way here, we're going to investigate that a little later, but set builder notation again uses the curvy brackets. And it uses, we're used to seeing a lot of this with domain and range. This is where we get the domain and range. That's how we build it. You've been doing it for like 3 years now, since grade 10. You just didn't know it was called set builder notation. So domain and range, how we write it, it is set builder notation. We're just going to now write it and describe other sets. So this one is saying x such that x has to be a number less than 7. And then it says, comma, xen. What do you think the xen refers to? Right. X is an element of the natural numbers. So they're saying that gives us our category range. When we talk about our real number system, we talk about, in the real number system, we've got rationals, we've got the irrationals with the run-on decimals, but the rationals, integers, whole numbers, and natural. Natural is your smallest set of numbers. We call those the counting numbers, okay? You start at positive 1. Now, whole numbers, all they do is include 0 to that set. So it's all natural numbers plus 0, okay? Letter I, that's your integers. That's where you're opening up your number lines to negative numbers now and positive numbers. But still no decimals or fractions. Decimals and fractions are only found in the rational set, okay? Which we know from Unit 2, rationals. So, when we talk about set builder notation, this one here, we have to know which of these sets we're talking about. So since it told us that we are an element of the natural numbers, that means we have to be a number that is larger than 0, because 0 is not included in the natural number set. 0 is included in the whole number set. Okay? So you have to know which numbers are included per set so that you know what this set builder notation is referring to. Because it gives you clues about the answer. Okay? And that's what we're talking about. Okay, so we're going to do an example here on the bottom. It says, if I wanted to write this out, this one here says the number of elements in set A, I would write it as, that should be NA, not an M. That should be an N. That's a typo there. That's NA, and that should be NA. So in this case, NA equals 6. N refers to the number of, okay? The number of elements in the set. Okay, that's what the N refers to. That should be an N, not an M. Okay, so whenever you say, for example, if I said to you, like we just saw here, set A was numbers 1 to 6, and there's 6 digits in there. That's why we write the number in set A is 6. Remember, the equal sign, we would read it as the word is. Okay, that's why they write it like that. This example here, it says, consider the following two sets. And we're going to list the elements, meaning the items. What will we find in each set? So P, this is set P. It says, even natural numbers less than 11. So we want to list the natural numbers less than 11. So here's set P. All right. Natural numbers. If I know it's a natural number, it's got to start with 1. And then it's going to go all the way to 10 because it has to be less than 11. Now, we only want the even numbers. So am I starting at number 1? No. So we're going to say 2, 4, 6, 8, 10. And put our curly braces back on. So that is set P.
Would it be okay if you like switch it if you like with 10 and 6?
It does matter.
Okay.
It's in ascending order, smallest to biggest. Okay. Odd natural numbers less than 11. Yep. Yep, you betcha. So here's all of our number systems again. So R stands for the real number system. Q stands for rationals. Okay. That's where we get our decimals and our fractions. Okay. Every kind of decimal except the run-ons. The run-ons are the irrationals. That's your run-on decimals there. Okay. Integers, that's your negative and positive numbers. I crossed off W because we were talking about N. W is the whole numbers. Whole numbers is all the natural numbers plus 0. Okay, so the counting numbers plus 0. And again, these go to positive infinity. So they carry on forever and ever and ever. Okay? I'll give you a minute to write that down. Okay, we're just going to continue now. We're going to write set Q. So set Q, it says odd natural numbers less than 11. So this time we're going to start with 1, and we're going to do all of the odd numbers. So set Q, 1, 3, 5, 7, 9. Will I include 11? No, because it says less than 11. Good job. So we will end at 9. So what is the number of elements in set P? What is the number of elements in set P? 5. Good. What is the number of elements in set Q? 5. Good. Now, do those elements have anything in common? What do they have in common? Any of these numbers? They're all natural. That's the only thing they have in common, because they've been separated now into odd and even. So the only thing they have in common is that they're natural numbers. So if I were to say to you, draw me a picture of what that could look like, you would have 2 separate diagrams. One of even numbers and one of odd numbers. Okay? Let's take a look at the next one. Now we're going to talk about different types of sets we can get. So, the universal set talks about, in every problem for set theory, there's one set that is the largest set that contains all the elements of the problem. And that set is called the universal set. So it is the biggest set that includes everything. So if I were talking here about our school, the universal set would be H.J. Cody School. If I wanted to pick a subset of that, which is example 2 here, subset is another set contained within a set. So if I'm saying my set is, my universal is our school, somebody give me an example of a subset. Grade 11, grade 10, staff. Okay, so those are all different types. You could even break it up even further. You could say athletes. You could say scholar academics. You could say the rap program kids. There's many ways we can divide it up into subsets, okay, other than just grade levels versus staff.
Can you do like a classroom?
Absolutely. You could say a subset could be just our classroom right now. Absolutely. Okay, so let's take a look at the example for number 1. We have the universal set of natural numbers. A set that's inside that set is set A, set of positive even numbers. So positive even numbers are in the natural number set. So A is a subset of the universal set. Okay? Example 2, students attending each day. Here on letter B, well, grade 10 students. They're just part of our school, part of our student body. So that means B would be a subset of the universal school set. Okay? So the subset symbol looks like a squished letter C with like longer arms. So this is the symbol right here. Okay, that sideways C, it's like a little bit squished. So if I wanted to say A is a subset of B, it would be written this way. A is a subset of B. Okay? In every element, or sorry, A is a subset of B only if every element is inside it. So let's take a look at some examples over here. I have set S and set N. Are all of the letters in set N inside set S? Yes, they are. Because S has an A, N has an A. S has a B, N has a B. S has a C, N has a C. All of the N letters are in set N, or set S. That means this set is completely inside that set. So because it's completely inside the set, we say it's a subset. Okay? A lot of S's there. Now we're going to talk about the complement of something. Now this doesn't mean I'm telling you you're awesome. This is a different kind of complement. This one means it's a set that is everything, including all the sets that are not in another set. So, for example, if I were referring to our school again, and I said to you, our universal set is H.J. Cody, and then I said to you, our set A is grade 12 students. The complement to set A would be grade 9 students, 10 students, 11 students, all the staff. It'd be everybody except the grade 12s. Okay? So that's what we know a complement is. It's everything except the other set you're talking about. Okay? That's what we do for a complement. So we have a couple different symbols for a complement. So if I said set A, the complement would be written A prime, and we read it as prime. And it's a little exponent to the top right of the letter. Okay, that's how we always put it. Now, you could also see it written with a line over top, a negative sign over top. Both are used. The one with the prime tick is usually used more often. You're going to see that more often. However, you will see this negative sign on top the odd time. So you have to know they mean the exact same thing. They just talk about the complement. So, here's an example. Set U is our universal set. So we're going to talk about all natural numbers. So the numbers 1 all the way to positive infinity, no fractions, no decimals, no negatives, and no zero. A is a subset. It says, here's a set inside, and it says it's going to be a positive even numbers. Okay, positive even numbers. What could be a complement to the positive even numbers? Positive odd numbers, and that's exactly what they've got written here, as the complement says positive odd numbers. Odd is everything that even is not. Okay? So that's another way to state the complement. It is everything your set is not. Okay? Yep.
So then, what the, like in the first example we did, would those two be complement?
Yes. Yes. Very good. So in the very first example right here, set P and set Q, these are definitely complements. How come? Because what is the complement to even? Odds. What's the complement to odd? Even. And they give you in the set range. Okay? So yes, we did deal with a complement example. All right. Then we talk about disjoint sets. Disjoint sets have nothing in common. So we could also say we had complementary sets that we started with, set P and Q, odd numbers and even numbers. But they're not just complementary sets, they're disjoint. They're disjoint, which means they're not connected at all. They have nothing in common. So this is more for when I would draw something. If they have nothing in common, I am not going to connect their circles. We're going to start drawing circles soon here. Then we talk, so for example here, we've got set A is talking about colors, red, blue, and green. Set B is talking about numbers. Do numbers and letters have anything in common here? Absolutely nothing. The only thing they would have in common is if they were on a spinner, and the spinner numbers were 1, 2, 3 with those colors. That would be the only possibility. Other than that, they have nothing in common. So that's why we call them disjoint. Oh, that would be a good one, actually. But they would have to tell you that every letter in the alphabet corresponds to a numerical value, okay, consecutively. So if that were the case, then yes, for sure. The next one talks about an empty set. An empty set is a set that has nothing in it. So, an example, I could say to you, I could put a set C up here. Set C could be completely empty. There could be nothing in it. Okay, that would be considered an empty set. Okay? Now, where are we going to see empty sets? Well, you see empty sets everywhere, but you're not really, we're used to kind of ignoring them when we speak about them. So, for example, if I were to talk about an empty set in our class, an empty set would be students not on crutches. I'm joking. I had to put that one in there for you. No.
Cripple, right?
Click on the cripple, yeah. Another empty set could be students with 5 legs. It's an empty set, it doesn't exist. Okay? Students with 55 arms doesn't exist. Okay? Those are empty sets. Okay. Here's some example of sets, and this is how they're written. So this is just a review to show you what they are. So set S is a set containing 5 elements, or 5 objects, or 5 items. Therefore, NS, the number in set S, is 5. Okay? So, there's another symbol we have here. The E with the line, the strike through it. That one means they are not an element of the set. So, this one is saying D would not be an element of the set N natural numbers. So that means the value of the D numbers would have to be any number other than a natural number. So that means they would have to be either a whole number, integer, rational number, fraction, decimal, something other than a natural number. Okay, that's what that one's telling us. Now we're going to look at some symbols and we're going to write our symbols. Let's see what they look like. So, E with the line through, looks like a funny E, means is a member of, okay? Our squished little C means is a subset of. This one is a U, a tall U, a squished U. Now that U there stands for OR, and we're going to discuss OR more when we talk about the next section in part B. Then we've got the upside down one. So we got the hill and the valley. So you can call this guy the valley, this guy the hill, or you can refer to it as a U and an N. Doesn't matter to me, whatever you think is easiest. We've got the complement. We already know what those are talking about. Empty set. Empty set could also be written like this, 0 with a strike through, meaning there's nothing there. Okay? Both of those refer to empty sets. So now we're going to write down what this would mean. Okay? We're going to try and describe these. So, if I want to describe set A, so it says using words, describe what's contained in every set, listing the elements. So, how would I describe set A to you then? What would we say that is?
Numbers less than 21.
Okay, numbers less than 21. Could we put a category to it? Natural numbers, good. Why would I say natural numbers is a good fit? Because there's no 0. There's no fractions, there's no decimals, there's no negatives. Okay? So, these are going to be all natural numbers between 1 and 20 consecutively. So all natural numbers between 1 and 20 consecutively, pardon me. So consecutively means in that order, in order. So every digit, one right after another. Yes?
You don't have to say, or I guess maybe you said it, you didn't write down, you don't have to say the set of, because there is a little.
We should say the setup, yes. So we should say A is the set of all natural numbers. Very well said, thank you. Then we're going to talk about the next one. This one is written. Does it describe anything differently from set A? Take a look at the way it's written. Whenever we see brackets written, brackets written this way, or sorry, symbols written that way, what does that mean? Between, good. So, and the line underneath means it can include that number. So it means numbers between 1 and 20, including 1 and 20, and it says X is those numbers, and the category is natural. So would it be described any differently than what we described for set A? No, it's identical to set A. So this is identical to set A. It is just written differently. So this one is written more in set builder notation, using the symbology word versus just writing all the numbers in order. Okay? So, can you write all the numbers in order? Absolutely. But you do have to know how to do the set builder notation. What does the front part refer to? Well, it always states X such that it is. Okay? So basically it's just a formal way of saying, hey, this is what X can equal. Okay? Let's take a look at the next three examples on the top of your next page. So letter C. Now this one says it's got something very, very different. It says C is equal to 2 times X. What is that telling me? That my C numbers, yeah. Pardon me?
Even?
Yes. Pretty much. That's pretty much exactly what they're telling you. So what they're saying is they're saying take every number between 0 and 20 inclusive and times the X numbers by 2. That's what this is telling us. So it's saying set C is every X number from 0 to 20 that is multiplied by 2. So basically we're saying we're counting by 2's. Okay? So 0, 2, 4, 6, 8, all the way to 20, including 20. So this is all. Well, we better state it formally. Okay. Set C is all whole numbers all whole numbers that are even between 0 and 20, inclusive, actually we say, inclusive. Inclusive means we include the 0 and the 20, okay? So set C is all of the whole numbers that are even between 0 and 20 inclusive. So basically you're counting by 2's. How would that question change if I put a 5 there? What would that do to the numbers?
Go up by 5.
Yeah, we'd go up by 5's. We'd be counting by 5's instead. Well, let's take a look. Let's do set E right away because it's very similar. We're saying set P is 3 times our X values. So we're going to say set E is all whole numbers Now, are we talking odd or even in this case? Are they all going to be odd or even? Does it have to be odd or even? No, we call this multiples of 3. Between 0 and 21 inclusive. So multiples of 3 mean you're counting by 3s. So 0 times 3 would be 0, 3, 6, 9, 12, etc., all the way to 21. But we couldn't say they were all even numbers or odd numbers because there's a mix of both. So they're counting by 3s, but we can't just say that. If we want to say counting by 3s, we say multiples of 3. Okay? So, counting by, we would say multiples of. That's how you would actually say it for our written expression. Okay, I'll give you a minute to write that down. Try and work on set D while we're waiting, okay? Set D. So, set D is talking about numbers between -1 and 12. And why do they tell us XEI? Because we have a negative number in there, right? So they have to tell us we're dealing with integers because we show a negative number. So now we're going to say, how would we describe this? We would say set D, not said, set D is the set of integers between 1 and 20 or 12 inclusive.
Would you put -1?
Yes, thank you. It is -1 and 12 inclusive. So inclusive again means all the numbers in between -1 and 12. Okay? So I'll give you a couple minutes. Try and write down 3 examples on the bottom of the page. Okay? I'll give you a couple minutes. Push pause now and play when you're ready. Okay, let's take a look. We have the numbers in order 2 to 8. So we want to say X is going to be between numbers 2 to 8. So I put the lowest number on the left, and then I put my arrows and my X. So I put my lowest number, then my highest number. And now I got to give a category. What types of numbers are they? Natural. So I'd say X, E, N. Close my curvy bracket. Okay? What would you write for B? The dots are going on infinitely on the right. That's what those 3 dots mean. That carries on infinitely. Well, X has to be bigger than a certain number. What number does it start at? -2. So we're going to say X has to be bigger than or exactly the number -2. Now, since we started with negative numbers, what's our category? Integers. So XEI. Okay? Now, what do you notice set C is doing? It's counting by 5s, right? So when we have those ones that count by 5s, we rename our set here, and we say C has to be equal to, now we do what we put, whatever times our X. What are we counting by? 5, so 5X. Okay? Now what numbers do we multiply by X? So I multiplied by 1, 2, 3, 4, 5, 6, 7, and 8. So what numbers was X? 1 through 8. So I would say, yes, there we are, but now we're using 1, X, 8. And then we're going to say, what numbers do we have? We have natural numbers, X, E, N. Do you see why it's written this way? These numbers here, the 1 and the 8, those are the numbers that were multiplied by this 5 to get the list we have. Okay? So it's working backwards. You have to divide those numbers by the 5 to find out what you started with, right? Are we good to go on those ones? All right, let's try another example. All right, we're going to have even numbers less than 20 is set A. Set B is natural numbers less than 20, but they've got to be divisible by 4. So divisible by 4 means it's a multiple of 4, they're counting by 4s. Divisible by 4, I want you to write counting by 4s. Okay, counting by 4s. Prime numbers less than 20. So we need to be able to list all these numbers first. So if I've got numbers less than 20, less than 20, and less than 20, that's what they're saying in every set. Less than 20, less than 20, less than 20. What would be a good universal set? Natural numbers less than 20. So natural numbers less than 20. Now, if we were to write that in symbols, we would say n less than 20. So natural numbers less than 20. That's our suitable universal set. Now we're going to list all of our sets. Well, if I want set A, all the even natural numbers up to 20, not including 20. So I'm going to start with, do I start with 0 if it's a natural number? No. We would start counting with 1, so the first even number is 2. So set A is 2, 4, 6, 8, 10, 12, 14, 16, and 18. All right. Now on letter B down here, we want to list set B. What are the elements in set B? Right, multiples of 4. So again, then we start with number 4. And we add 4 every time. So 4, 8, 12, 16. If we add 4, we get to 20. And we're not allowed to use the number 20. So that's the end of our set. Okay, so there's only 4 numbers in set B. Set C wants the prime numbers less than 20. This is where we have to make a note. 0 and 1 are not prime numbers. Your first prime number in any list will be a 2. The number 1 is not a prime number, neither is 0. Okay? The definition of a prime number is any number that multiplies by 1 and itself, but has different factors. That's why 1 is not a prime number, because the only other number you can multiply to 1 to get a 1 is 1. And they can't be identical factors. They have to be different factors. Okay? That's why 0 and 1 are not prime. So, our first prime number then is 2. Then 3. Then 5. 7. 11. 13. 17 and 19. We have 8 numbers in our set. Now, what does A prime refer to on number 3? What does A prime refer to? How big is A prime? What are we referring to? What am I asking you for? What does this prime tick refer to? The complement. So I want the complement of A. What that means is I look at set A and I write every number that's not in that set, that's still in our universal set. So the complement of A is everything A is not. So we're going to write down now the complement of A. So the complement of A, number 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So it's all the odd numbers between 1 and 20. So it's everything that set A is not. Now we're going to find out whether the following things are true, and we're going to label what's in each set. So, B subset of A. If B is a subset of A, that means all the numbers in set B are inside set A. So if we look at set B, and I'm going to highlight it down here for you. Here's set B, 4, 8, 12, and 16. Are all of those numbers inside set A?
Yeah.
Yes. So this is a true statement. What about letter C? Are these numbers all inside set A? No, it's false because there's some odd numbers in there. Well then, how about A? Is the even numbers, all of set A, is it inside set B? Heck no, that set B is too small of a set. Okay, so that one's false. Aha. The next question is saying, is set C, that I'm going to circle here, is set C a subset of A prime? Meaning, are all of these numbers inside there? No, because of this 2. Otherwise, they would be. Okay? So almost. That is also a false statement. Okay, we have a couple of more examples to look at here. This is an example of Canada. So we're saying our universal set is Canada. So that's why we've got C as the universal set, referring to Canada. We're just going to write the initials of the provinces. So what we do is we would write all of the words of the provinces, or we would list them. We're going to go left to right here. So we got BC, Alberta, Saskatchewan, Manitoba, or is it MA for Manitoba? Yeah, I think it's MA, right? Or is it MN? I can't remember.
I'm gonna Google it.
MB? Oh, and it might be MB.
Yeah.
Manitoba, MB looks good. I think you're right. Then we've got Ontario, Quebec. Then we've got who else? Or QE. Then we've got who else? After Quebec, we've got New Brunswick. We got Newfoundland. We got PEI. We got Nova Scotia. And we've got our territories. So, all territories. So that's all of Canada. What do you think they're showing set W to be? What would they say set W would be then? And why would they name it a W? The West, good. So they said a subset of C, so a set found inside all of Canada, is the West. So for the West, we've got BC, Alberta, Saskatchewan, Manitoba, and all the T for territories. Okay, so I put all T for territories. So if we wanted to draw a picture of that, our big box here is our universal set of C in the corner here, Canada. They're always going to name the universal set in the top right-hand corner. Always, always. Then they're just going to draw a diagram of your set inside it. So here's all of our West provinces. Okay? And territories. What would be the complement to the West? The East. Good. So it is all East provinces. So all Eastern provinces would be the complement. So we could also say, well, that is right here. E for Eastern. So there's our Eastern provinces. Quebec is QC. All right. Now, is E equal to W? Is the East equal to the West? No, there's nothing identical about it. They're completely different. Okay? Well, let's take a look at the next example. Now we're going to talk about intersection of our sets. Now we're going to talk about where do they overlap. So this one says, an intersection is when two sets have the same elements or items. So we use the set symbol N to mean the intersection, meaning they overlap. So intersection means there's an overlap. Think of it as the and. So we would read this A and B. And that means elements in both A and B. Okay, the overlap between them. Whereas the union means everything in both. So it means all this one, or both. So we would just say the union is all of both sets. Okay? All of both sets. And we would write our symbol as AUB. AUB would be read as A or B. Meaning it could be all of A, or all of B, or both. Okay? Now we're going to try an example like that and see how far we get here. It's going to be our final example for this lesson. So we've got natural numbers less than 20 divisible by 3. So listing set A. So on the top of your next page, it wants us to list set A. But I'm just going to list it right beside here so that I'm on this screen. Oh, I can list on the second screen, that's fine. Okay. So elements of set A. We have natural numbers less than 20 divisible by 3, meaning we're counting by threes. So 3, 6, 9, 12, 15, and 18. There's set A. Set B says numbers less than 20 divisible by 5, so we're counting by 5s for set B. 5, 10, 15. We can't include 20 because it says they're less than 20. Let's do set C on the bottom right. It says natural numbers that are divisible by 6. So we're counting by 6s. 6, 12, 18. Now I left A prime out on purpose. What is A prime asking for? The complement of A, meaning everything that's not in set A, but it's still in the universal set. Well, our universal set is between 1 and 20, but you can't include 20, so basically 1 to 19. So I'm going to list all the numbers that are not in this set that go all the way up to 19. So 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. That would be the complement of A. It's everything A is not. Yes, it can include other numbers from other sets, absolutely. Now we're going to list what they're talking about here. So what does our first symbol refer to? And. The and means the overlap. So what do A and B have in common? So if I were to look at what A and B have in common, what number do they have in common? 15. So I would say 15 is what they have in common. And I'm going to put it in my little curvy brackets. Now, if they had any other numbers in common, I would circle those and write them down as well. But 15 was the only number between those two sets that was the same. A or B. What is A or B asking for? Everything from both sets. All of A and all of B. Now, if there's a repeated number like 15, you only write it once. And again, you write it in numerical order. So I'm going to have 3, 5, 6, 9, 10, 12, 15, and 18. Okay? So it's everything from A and B. Because this is the OR symbol. So all of A and all of B. That's what you list. All of A and all of B. That's what OR means. All of A and all of B. What does the third symbol refer to? A prime and B. The intersection of A prime and B. So now I'm looking between A prime and the B. What do they have in common, if anything? The 5 and the 10. So they have two numbers in common. They've got a 5 and a 10. Okay, let's try to write the ones that are equivalent to B and C. What's B and C referring to? It's the and symbol. So we want the overlap, the identical items, repeated items in B and C. Is there anything in common from B to C? Nothing. So that's an empty set. We can write it two ways, like this, or braces with nothing in it. Empty set. There's nothing there. A and C. What about A and C? So I'm now going from A, I'm going to highlight it in yellow, and set C highlighted in yellow. So what do those sets have in common? All three numbers. So how would we describe that then? Yes, C is a subset of A because everything in C is inside A. Well done. Uck. AUC. What is AUC asking about? It's the OR. So if we look at the OR symbol from above over here, what did I do? I did all of them for both sets. That's what you do for this guy. That's all of A and all of C. Well, C is a subset. So basically, if I write all of A, I include C anyway. So all I have to do is write set A. So here's set A. 3, 6, 9, 12, 15, 18. All right. Number 4 says, we have another set now. We're going to include set D. Even natural numbers less than 20. So now we're going to have set D is, I'll do him in red, and I'll move it up a little bit. So set D, even numbers less than 20, starting at 2, 4, 6, 8, 10, 12, 14, 16, 18. Cannot include 20. So there's set D. We need to always list it out so that we can solve the next question. Now, these ones have multiple operations. So we have to read. They're going to be a little silly when we read them. So we're going to go through it slowly. First one says, A overlapping with, now I got to find this part, all of B and all of D. So where does A overlap with anything from B or anything from D? Well, this is where we go through and we make check marks and we start matching things. So now I'm going to match, okay, what is in set B or D that A has in common with B or D? Okay, well, is there a 3 in set B or D? No, so I'm not going to use the 3. Is there a 6 in set B or D? Yes, so I'm going to use a 6. Is there anything 9 with set B or D? Is there a 12 with set B or D? Is there a 15 with set B or D? Is there an 18 with set B or D? Yes. So this is my overlap from the A list to anything in B and D. So these are the numbers that overlap in sets B and D. That's what we wrote down. And if you're not sure, write down that we did, this means the overlap with sets B and D. Anything overlapped with sets B and D, that's what we're finding here. So if you ever see a situation like that again, you got to figure that out. So make sure you write these down. All right, the next one. How would we read the next one? A and B. So the overlap of A and B. Okay, let's go up and see if there's an overlap between A and B. 15, okay. So it's saying that or anything in the D list. So the number 15 or anything in the D list. That means I list that number 15 and the whole D list. Okay? So this guy would be D list and number 15. I'm just not writing it down. I don't have space. Okay, so in brackets you would write all of this D list and you would put the 15 in between the 14 and 16. They have to go in numerical order. Okay? The next one looks a little silly. Look at all them prime ticks. Okay. Now, this guy says everything that's not A, so we listed everything that's not A. We have an A prime list, overlapping with everything that's not B. So we need to make it everything list that's not B. So I need to make my lists. Where's my list here? A prime. So I'm just going to write my lists down here so I can see them better. A prime. Okay, got a couple minutes to take a look at this stuff. So in the next one it says, we're looking at question I here, triple I. It says the complement of A, which we listed here, overlapping with the complement of B. So we want to write down everything that they overlap. So let's just circle what they overlap here. So if I were to highlight, 2 is in common, 4 is in common, 7, 8, 11, 13, 14, 16, 17, and 19. So, and then this little tick outside says the complement of that. So it wants every number in the universal set that doesn't include those numbers we just highlighted. So that's going to include, and this is again for number 3 here. So this is going to include number 3, 3, 5, 6, 9, 10, 12, 15, and 18. Okay? So those are the numbers that are the complement of what A prime and B prime have in common. Now the next part of number 5 says write sets equivalent to the following. That's actually a typo. It should say true or false for the following. So let's take a look at these following examples. We have 3 examples. So it's saying C is a subset of A. So that means is all of list C inside set A. So if we take a look, we already discussed set C, which is highlighted in yellow, is completely all inside set A. So we would go down here and we would say, yes, that is true. Now, the next one says C is not a subset of B, meaning is set C not inside set B? Well, let's give a check. Is set C completely different from set B? Yes, it's completely different, and it's not inside that set. So we would say that's true, because it's saying it's not a subset. So that is true, they are not subsets of each other. Number 3 says, is A prime, so this whole list here, is that list a subset, so completely inside, set C prime? Does it include all of those numbers? Well, let's check. So, we've got the number 1, 2, 4, 5, 7, 8, 10, 11, 13, 14 is the same, 16, 17, and 19. So is all of set A inside, or A prime inside set C prime? Yes, it is, so it is also a true statement. Okay, this concludes our first lesson, 4.1, on sets, or set theory.